Okay, are we there? Alright, so yesterday we were looking at this OTA question. Okay, although with this kind of hint, I don't think anybody will want to eat OTA. Alright, so yesterday, okay, there are certain tips that I've given you, okay, in terms of answering matrices question. Okay, so the very first thing that we should always ask ourselves is what does the question want? So not limited to matrices, okay, any question, we must always know what is the end point. Okay, but specific to matrices, we need to know how many elements or how many answers or how many values are we trying to achieve, okay, at the end of our question itself. Okay, and then also what are the possible orders of the matrices. So that was how we guided ourselves in terms of solving part I yesterday. Okay, then we also thought about how will you normally achieve the answer without using matrices. Okay, that will help you think about how are we supposed to go about multiplying and doing our calculations. Okay, then we want to also form a matrix with the same order as presented in the table. So usually no change to how the order of the matrix is like. And then we also figure out what is the second matrix. Okay, today I want us to look at part 2. Okay, whereby it says that in December, the Tampines, Bedok, City Hall, Toa Payoh, and the Jurong East outlet, that means all the 5 outlets that we have, they receive 45, 42, 38, 55, and 52 deliveries every respectively, okay, in December. So we want to write down 2 matrices such that the elements of each product give the total number of sticks of each type of OTA, okay, supplied by the factory. Okay, so this is our end point. Okay, where we want the total number of sticks of each type of OTA being supplied by the factory. Okay, there are 4 different types of OTA. Right, and then 5 different types, 5 different outlets itself. What the question essentially wants is the overall output from the factory itself for each of the type of OTA. That means that we want 4 different values at the end. Okay, so looking at part 2, okay, we want 4 elements, 4 values. Okay, and what we are looking for is really the 4 different flavors or 4 different types. Okay. That is your fish, prawn, squid, and mix. Okay. So, understanding the information that has been given to us, okay, what the table presents is how much is actually being delivered out in one delivery itself. So one delivery going out to Tampines consists of all these numbers. And then one delivery going out to Bedok consists of 120 fish, 0 prawn, 150 squid, and 140. Okay, so one delivery each. Okay, then after that, now we need to multiply all by 45. Okay, 42, 38, 55, and then 52. Okay, and then not only that are we multiplying it, I want to add up, okay, all these values over here to know, okay, 45 times 70 plus 42 times 120 plus 38 times 0 plus 55 times 200 plus 52 times 80, and then summing all of them up, okay, this will give me the amount for fish. And then I do the same thing, okay, for prawn, for squid, and for mixed seafood. Okay, so that is the calculation that we want to perform at the end of the day. Okay, but how are we going to achieve that using matrices? Okay, so I've done the thinking of question 1. Question 2, I've also thought about how is it normally done already. Now it is about forming the matrix itself. Okay, so you see that our part 2 question, we cannot run away from the information presented in this table. That means that I will definitely need my information found in the table. Okay, so I'll keep to that same order. and this order of the matrix is 5 by 4. Okay, so we're expecting to multiply this matrix either on the left with something or on the right with something else. Okay, we know that if I multiply by something from the left side, that means I have some matrix over here. It must be times of 5, okay, the order itself, and then we do not know what is this one. Okay, and then if I want to multiply something on the right, okay, I know that it must be a 4 by something matrix. Okay, but then if we were to look at this multiplication, okay, this set over here, the one on the right, what is the end result that I'm getting, okay, for the matrix? I will be getting a 5 by something matrix, which doesn't fulfill the fact that I'm looking for 4 elements. Okay, therefore multiplying on the right is not going to work out. Okay, so we need to multiply something on the left, because looking at this pair, I will be getting something by 4 matrix. Okay, so I can have a 1 by 4 matrix, and that will fulfill the fact that I have 4 elements. Okay, so we eliminate this possibility. Okay, so then I know that now I must have a 1 by 5 matrix, okay, in order to get myself a 1 by 4 matrix, okay, upon my multiplication. And a 1 by 4 matrix will be an entire row, okay, with 4 different values. Just trying to draw the stroke to show that there are actually 4 spaces. Okay, so what is going to go into this 1 by 5? Since we're trying to take these values over here to multiply, so I will think about using these values here. Okay, so a 1 by 5 matrix is actually a single row, okay, with 5 different values. That will be your 45, 42, 38, 55, and 52. Okay, so at this juncture, we think about having these 2 matrices multiply each other to get the 4 elements that we want. Okay, but then we need to think about, does it fulfill the requirements or not? Does it fulfill this normal arithmetic working that we're going to do? Okay, we said that we wanted 45 times 70 plus 42 times 120 in order to get the number of fish quota being delivered. Okay, so if this is supposed to give me the number of fish quota being delivered in December, I'm expecting my multiplication such that I take this row, okay, multiply with this column, right? Because this element here is first row, first column. So first row, first column, I am taking 45 times 70 plus 42 times 120 plus 38 times 0 plus 55 times this plus 52 times 80. And that is the exact calculation that we want to do. Okay, so we do that calculation using our calculator, and then we will be able to get 23350. I don't think I have enough space there. Okay, so we get 23350, and then I do the same in order to get my second element. It is the first row, second column, first row, second column. Doing the same form of multiplication, I will get 24520. Okay, and then now I will have the 4 different elements that I need. Okay, and they are the fish, prawn, squid, mix, and fish, prawn, squid, and mix respectively. Any questions? Give you a minute to digest and think about this. We're not done with this question yet. If I want you to think through the way the matrices are formed as well as how they are being multiplied. Right? In that same part, okay, we have very successfully answered the part about writing two matrices such that it gives this product, okay, and then we answer the question of achieving total number of 6. Okay? In that same question itself, it says obtain this product and hence find the total number of quota supplied by the factory to these outlets. Okay? So we want to find the total. Right? A very logically and very simple manner is that I just take these 4 elements over here, add them up together, I'll get the answer. Okay, so that is a purely arithmetic method, and there's nothing wrong with doing that. Okay, so the simplest method is to solve it arithmetically. Okay, recognizing what are these elements. Okay, and then we find the total number of quota supplied. And then we will get the answer of 82,000. Okay, so this one is a straightforward answer, right? However, I want us to extend our thinking. What if the question were to say to solve the question entirely by matrices? Okay, then what can we do? Right? So if the question says to answer solving by matrices, that means that I cannot just take the 4 elements here, okay, and then after that add them up together and get this answer. Okay, an alternative method using matrices would mean that I need another matrix that can multiply with this current one, okay, in order to get myself one answer. Okay, because I want 82,000 as my answer over here. Okay, I want a single 1 by 1 matrix, therefore there must be brackets. Okay, that will give me 82,000 as my answer. Right? So this matrix that we now have is a 1 by 4 matrix. Right? In order for me to get a 1 by 1 matrix, since this number 1 is on the left side, that means that I need to multiply something towards the right, which is a 4 by 1 matrix, so that I will eventually get a 1 by 1 matrix over here. Okay? So I need a 4 by 1 matrix. What shall the 4 by 1 matrix actually be that will help us in terms of the addition, okay, that we want to achieve? And this magical matrix here is a column matrix of 1s. Because by our matrix multiplication, in order to get first row, first column element, I will take first row, first column, where I take this number, multiply with this, plus this number, multiply with this and this and this. And then I add them up. Okay, so that is the usefulness of the column matrix of 1s. Okay, which explains why earlier on when I introduced to you row matrix and column matrix, I said that a row of 1s and a column of 1s, they are actually very important. Okay, it does help us in doing such calculations. Okay. So it's method 1 or method 2. Okay, you can do method 2 when the question actually specified using matrices itself. Okay. Otherwise, nothing wrong with doing method 1. Okay, there's nothing wrong with doing partially matrices and then after that partially in normal calculation. erase this part. Okay. Right, next we look at part 3. Okay. For part 3 itself, it says that using the information provided in part I and part 2, okay, write down two matrices so that the product will give the total cost of otah delivered by the otah factory to its 5 outlets in December. Okay. The easy one, okay, not sure lah, it depends on yourself also. Alright. The easy one is that we know the numbers, okay, for fish, prawns, squid, and mixed already. Okay. Earlier on in part I, we already know the cost over here, okay, which is 35 cents, 40 cents, 45 cents, and 38 cents. So you can take these numbers over here, multiply with this, okay, in order to know what is the total cost for fish otah. Okay, then after that, prawn multiply with 40 cents, squid with 45 cents, and mixed with 38 cents. However, the question specified using matrices, therefore you need to form suitable matrices and you cannot do, okay, normal calculations like that. Right? So how do we go about forming this matrix? Okay, we will be using this one. We'll be using this matrix over here, which is a 1 by 4 matrix. Okay, and the objective, the end goal that we want to get is a single value to represent the total cost. So I'm expecting, okay, my final answer to be a 1 by 1 matrix. And that can only happen when I multiply towards the right, where I have a 4 by 1 matrix. Okay, because my 1 by 1 needs to be formed by observing these parts of the order. Okay, so this 4 by 1 matrix will have to be the cost, okay, because we are trying to find the total cost anyway. So 35 cents, okay, then 40 cents, 45, and 38. And by checking our matrix calculation, we're taking this, multiply with this, plus this, minus this, and so on. Okay? Using our calculator, we will get 3217 3 zeros. Okay, and that will be your 1 by 1 matrix. The reminder is really to put in the brackets, because very often people tend to forget the brackets. Okay, forget that it is a 1 by 1 matrix. And then we conclude that total cost, this is in cents by the way, so we need to divide by 100, and that will give us 32,170 dollars. Okay. One way for us to solve this question for part 3, but it's not the only answer. In fact, I think these two matrices are the ones that your textbook's answer key will probably provide. Okay. I want to show another different method that we could do. Okay, also using part I and part 2's solution. Okay, so recall that in part I itself, we found out the total cost, okay, of otah delivered to each outlet. Okay, so this means that in the answer that we got in part I, let me just calculate this out. Okay, Okay, our part I's answer, if you recall, was 14340, 16270, 12105, 15750, 10810. Okay, so this matrix represented the total cost for Tampines, Bedok, City Hall, Toa Payoh, as well as Jurong East. And this total cost itself is for a single trip. Okay, remember we got this based on the table's information multiplied with the cost per quota. Okay, so this is in one single trip itself in December. Then there was another matrix being provided, or another set of information being provided, which is the number of trips, okay, that are being made in December itself. And this matrix itself is a 1/5 matrix, and this is a 5/1 matrix. Okay, so I could consider taking the number of trips, multiplying with the cost in one trip, and then adding up respectively in order to get the total value. So I'll just place this here. Sorry, I'm running out of space. So I'm a bit lazy to adjust. Okay, so this one on the left with this one, so this is a 1/5. We're expecting a final answer of a 1/1 matrix, and that will also give us 3,217,000 cents. Okay, and total cost is also, okay, in dollars, $32,170. Okay, so just an alternative way of solving for this same question as well. Right? I don't want us to be bounded by thinking of just one way of solving. There could be many ways of solving. Okay, the calculation remains the same. Because why am I presenting this tool? Okay, because some of us might be thinking in this manner, or some of us might be thinking in this manner. Okay, nothing wrong with either manners that you're thinking about. Okay, just that you need to know what matrix to use and what matrix to form and what matrix to multiply. Okay. Alright. So with that, okay, homework. Erase this, yeah. Okay. Want us to do exercise 4B, question 5 and 6, 4C, 4C and D, and exercise 4D, question 4, 5, 6. Okay? Please complete this on a single foolscap paper or continuous one. Don't need to do it separately. It shall be due on what's a good date for it to be due on? I'm saying that Friday I have an A-Maths homework due, and then after next week I have your A-Maths W. Tuesday? Okay, so let this be due on Tuesday, yeah? That will be on 25th. Okay, so that's done our matrices. Google Classroom, and at the moment I step out of class, okay, you will receive the WA2 revision, okay, for your matrices as well as the statistics, okay, on Google Classroom. our exercise 15.2 AMAX homework.